going to talk about today is to see how we can use MDTP to look at the data that you get from our tests or from our other components like the open response items, and see how you can use that data to bridge, you know, from what your students know right now to what they need to know to get ready for the following course. Okay, and we're going to try to give some suggestions about how to do it in a way that's equitable. And so the overview of this conversation is, and this is going to have a little bit of an intersection with what Kim already said, is we're going to overview the components of the assessment system and perhaps some suggestions on how you can use them. I think Kim did talk a little bit about that. So we have, our online, our multiple choice diagnostic test, and then we also have a couple of different kinds of written response items, and we also have the learning modules. And then we're going to talk a little bit about ways you can analyze the data to try to figure out what students know, what are some of their strengths, and what are some of the mistakes that they're making, some of the misconceptions or gaps that they may have, okay? And finally, we're going to try to see, have a few words about how we can try to address the students' needs in an equitable manner, some suggestions for reacting to the data, okay? So, like Kim already said in the keynote, we have the components of the assessment system are multiple choice diagnostic tests. We have two kinds of those. We have open response items, and we also have two kinds of open response items. And we have the learning modules, which is a more sort of recent endeavor for MDTP, because we, for the longest time, stayed just with diagnostics. As you know, our services and exams are free for any California schools, private, public, charter, it doesn't matter, as long as they're accredited by the CDE. Okay, so the diagnostic tests, okay, let me make this minimal. The diagnostic tests are multiple choice tests, and there's two kinds of them. We have one of those two kinds is the preparedness test and the readiness test. The preparedness tests are the tests to see if students are prepared to take math 6, 7, or 8, so the middle school courses. And then the readiness tests are readiness diagnostics for readiness for certain courses in high school, math 1 or algebra 1, math 2, math 3, or geometry, second year algebra, pre-calculus, calculus, things like that, courses like that. And so what we're trying to do is give you give teachers an idea of how well students are prepared in broad, important topics. And this is diagnostic information, so you can actually use it to see where students are having relative strengths, where they may have some misconceptions or some skills that are lacking, and where they may have some gaps where they basically haven't seen the material that they're supposed to know, okay? You can give this test throughout the year anytime you want. If you have an online account with us, you can just create the classes, set up the testing. I think Kim talks about that in the nuts and bolts, okay? And then we also have the diagnostic, the other type of diagnostic test, multiple choice tests, are the 9th grade assessments. There we have 3 of those. So these are assessments that you're giving your kids at the end of math, at the end of 8th grade. And depending on the class they're taking in 8th grade, you can give them the 9th grade assessment or the geometry assessment or the integrated second year assessment. Supposed to be one of the measures that you can use to inform what class students are going to go into in 9th grade. So this is a test that we developed to try to help schools comply with SB 359, which had basically, we have a whole webinar about this, but essentially this Senate bill wanted schools to have a clear, transparent, and equitable, uniform way to make decisions about how students are going to what classes they're going to take in the 9th grade. And so the two components that they wanted schools to enact was towards the end of the 8th grade, have some sort of a test that would inform that decision. It should be one of several points of data. You shouldn't just base the enrollment based on one test, of course, but to have one that's uniform and transparent. And then then once the students are in 9th grade, at the beginning, towards the beginning, in the first month or so, to have a checkpoint to see if the students were actually placed in the correct course. Okay, and so for that we would recommend one of the readiness tests, for example. But yeah, we have a whole webinar about that topic. So again, these were designed to help schools make that decision where are the students going to go when they come into 9th grade, and because you give them at the end of the school year, so you don't really have that much of a chance to give your students a diagnostic test at the beginning and then work with that data toward during the year. But you can still use this exam in a diagnostic way, and in particular, it can help you make decisions about how the department is doing as far as preparing students into 9th grade. I think Kim mentioned in the keynote that these tests are a little bit higher stakes, and so for security purposes, they are only online, and also they have to be taken in one sitting only, whereas the other tests, the readiness tests, you can stop them and continue the following day, for example. Okay. All right. So those are the diagnostic tests. Then we also have open response items, and there's two kinds of those. There's the written response items, and then there's the formative constructed response items. The written response items, both of them are they're basically aligned to the topics, to the broad important topics of the MDTP tests, of the multiple choice tests. And the written response items give you an opportunity. These are items where students actually have to write out their solutions to prompts. They are more like performance tasks, like I said, open response tasks. So they can also help you a little bit with trying to prepare students for that kind of assessments, the performance assessments. And they give you an idea of how students are thinking about math and how they're communicating about it. So it's a more in-depth look at what the students are thinking and doing. And the written response items range in level from basically from middle school to pre-calculus or calculus, actually. Okay, and you can give these tests to your class, and you can have one of the things you can do is you can have students look at each other's responses, for example, if you want, and we also provide a rubric for scoring them. But Pat and Carol are going to talk about that in their session. If you want to go to that in the following week, okay? Then the formative constructed response items are a little more kind of focused. The idea of these ones is that you give a diagnostic test and you look at, you find out that there's a topic where you want to focus more attention because maybe the students are not doing so great. These items are actually sort of spin-offs of particular items or questions in some of the multiple choice tests. And so the idea is that you look at a problem where students, for example, may have some gaps or misconceptions, and then you make some interventions. So you address the issue in your instruction, and then you give them one of these tests, one of these items, to see if the intervention has worked. Okay, that's the way we envision this to be used. So both these ones and the written response items really should be done in the classroom where you can actually see how students are engaging with the problem and talking to each other. But then the other component, the last component that we have, is these learning modules. This is more designed for students to do independent work. Okay, so if you have identified that some students are lacking a little bit in some topic, you can go and look at the modules and assign some of those to them, and they can do them on their own. So these modules are composed of several lessons, and in the lessons there are 5 different components. There's exploration, examples, there are videos, then there's a section on making connections, and then there's practice. And the idea is to sort of bridge from the level where they are at towards a pre-calculus level. Okay. So those are the learning modules. Some suggestions. I don't remember if Kim talked a little bit about this. I think she may have. So of how you can use our diagnostic tests during the year. This is an example. If you have an Algebra 1 class or Math 1 class, where towards the beginning of the year, you can just give them the readiness test for the class that your students are just beginning with you. Okay. And that gives you some baseline information. You can identify some strengths, some misconceptions, some gaps. We're going to talk about that in just a moment. And you can try to start looking at that data and using it to plan ahead for the course and see where your students are, what are the things that you need to review, or what are the things where you're happy that the students already know, and you can build on those. Okay. Then a few months later, you can, if you want, you can check on the growth. If you made some interventions based on that data, see if there's been some growth related to that. Okay. But then during the second part of the year, you can start gathering baseline data for to see if the kids are ready for the next core. In this case, you give a geometry readiness, or second year math if you're in an integrated curriculum. And so again, you start gathering some baseline data for that. And closer to the end of the year, so in the middle of the spring or something like that, you can actually give them this test again to see, okay, are my kids ready for geometry, or are they ready for math 2? And you can, if you gave them the test in the middle of the year, you can also check on the growth that they've had since then. Okay, and because this is now the end of the year, you can also get together with your colleagues and try to make some decisions about or some reflection about the program. What are the things that are working well? Where are the topics where we need to perhaps pay more attention for next year, and things of that sort? Okay. So the diagnostic tests, basically what we're trying to give you is an idea of how well prepared your students are to be successful in a certain core. Okay. And so we do that in a diagnostic way, so that you can get an idea of where students have strengths, where they have weaknesses or unfinished learning, and where they just have complete gaps. Especially now with the pandemic, I think it's after the pandemic, there may be more gaps than there used to be in a typical incoming class that you get. And so how can you try to identify some of these things from the data that you get from our tests? Okay, well, the data that you get from our tests, you have different sorts of data. You have class readiness data, okay, and it gives you an idea of the overall readiness for the students in the different topics, sort of important broad topics that we write to the tests to. Okay, and that again gives you some of the first basic baseline information that you can use for planning your whole course or big chunks of units. But then you also have data from each of the items on the test. So each of the questions of the test, you get an analysis that tells you how many students got that right, who were those students, how many students got different choices, and who were those students who made those different choices. And so that is gives you more fine-grained data that you can use to identify strengths and unfinished learning and gaps, both individually and as a class. Okay, and so that allows you to plan for more for smaller chunks like lessons. Okay, and intervention related to some misconceptions, for example. And then, of course, you also get a student and individual results. So for each student, you see the did on each of the topics, what are the problems that they got right, what are the questions that they missed, and so on. So that allows you also to see you need to address students' individual needs, and you can also try to have some differentiation, okay, or grouping that will be productive. So some students may be able to help other students based on their strengths, or if you want to do some differentiated instruction, you may want to have students in a group that you will need to address this particular topic with them, and you need to address this other particular topic with this other group. Things of that, decisions of that kind, okay? So here's an example of what the class readiness, overall readiness looks, okay? This is an example for, say, an Algebra 1 and Integrated 1 readiness test. It lists the topics on the exam. So what you see on the left are all the topics on this test. These are broad, important topics that students need to really be able to master in order to be successful in Algebra 1 or Integrated Math 1, okay? And then it tells you how many questions there are in the test for each of those topics and what the critical level is for that topic. The critical level is what we consider to be the minimum correct score on the topic, so that to show that the students are well prepared in that topic to be successful in this case in Algebra 1 or Integrated 1, okay? So that's the critical level. And then it tells you both by number of students and as a percent of the class, how many students scored at or above that critical level, all right? And so, as an example, say suppose that in the next unit you are going to have a unit about solving linear equations. Then there are some topics that you may want to pay more attention to than others, right? In this particular example, you really may want to focus on these topics: fractions, integers, and linear equations. If you're going to be doing a unit on linear equations next, okay? So another thing that you get, so the item analysis that you get it in in two categories. One is that you get all of the items in any one of the topics. So you get the items grouped by topics, and then within that topic, you have a list of the items and ordered by performance. So, for example, in the topic of fractions, these were the questions on the test: questions 4, 25, 17, 16, 14, and so on. Those were the questions on fractions, and they're ordered by performance. So the students did relatively well in number 4. They really didn't do so well in number 31. And you can try to then see what are some strengths, what are some possible gaps where students really have very little clue, and where is somewhere in the middle where they have some unfinished learning. There's some more work to be done there, okay? But you also have an item analysis for each of the questions. You see how they responded how the students responded to those questions. And so strengths are usually, so if you're trying to identify strengths or misconceptions or unfinished learning or gaps, strengths are probably going to be items where most of the students were able to answer those correctly, okay? But unfinished learning, you may be able to identify some of those because either students may have overwhelmingly chosen a particular distractor, a particular incorrect answer, and in that case you have a misconception, okay? Or all the answers may have maybe more or less evenly spread, and so then they have about the same number of students chose option A, B, C, D, and E, and then this could be more of an informed guess or all over the place. But students are not necessarily getting it right, but they're not going for a particular mistake or misconception. Okay, so those are questions in the test that may allow you to identify, okay, here's some unfinished learning, and what am I going to do about it? And finally, gaps could be problems where a lot of students omitted the question. So we encourage teachers to tell students not to guess on this test. I mean, if they have some idea of where to go, they should maybe make an informed guess. But if they really have no idea how to approach a problem, they should leave it blank, because that will give you useful information. If they guess with having no clue and they get it right, then what you see is that they got it right, and you don't know that they have a gap there, okay? And that's not good for addressing their needs. Okay, so here's, we're gonna stick to the concept, to the topic of fractions to do some examples. And so here's a question from the test. What is the integer that is closest to 31/7? So you look at the choices are 1, 3, 4, and 5. The correct choice is C, 4 is closest. And you can see that 57% of the students actually chose that. Of the ones who missed it, 20% chose 5, which is sort of okay, in the sense that 31/7 is between 4 and 5, right? So it's not as bad as, choosing 1 or 3. For the students who chose 1 or 3, you may want to have some individual attention, some individual intervention, and try to figure out what's going on there. 9% omitted. It's not a huge number, but it's also somewhat significant because this is only the 7th question in the test. So about 1/10 of the class didn't know how to deal with this, and so that is something that you should pay attention to. But for the most part, this is a strength, because the majority of the class did know how to answer this question correctly. Okay. All right. So here's another example, and the question is, in the figure below, what fractional part of the circle is shaded, right? So I'm going to actually give you a little bit of time now to, take out a piece of paper and pencil and work out this problem. And then we're going to look at what students did. Okay, so why don't you take a moment to do this problem. Oops. There we go. All right. Okay. So what do we have to do in order to solve this problem?
And that question is to us?
Yeah.
In order to solve that problem, students would have to understand the whole and really look at the way the circle's partitioned. So meaning that I have a third and I have 2/5, and those two parts have different denominators. So a lot of layered understanding involved.
Yeah. But so what do they have to do with those fractions in particular?
Find common denominator.
To do, to do, why do you want to find common denominators?
If they understand that I'm working with fractions, I need to add like fractions. So in order to do that, I would have to think about what the commonality would be to find a common denominator. But then on top of this common denominator, I also have to think about what's the whole. Right.
So they need to add those fractions, right? And for that, if they want to do it correctly, they should find common denominators. And then, like you said, there's also, that's not it. That's not just they also have to then look at the whole and then to subtract from the whole, right?
Yes.
So those are the things they have to do. So let's take a look at what students did. Those are the choices.
Oh, yes.
Yeah.
So, I was
4/15.
thinking about what the actual answer was, and I thought, what might students do? They may add 1/3 plus 2/5 to get 3/8, and I'm looking at 3/8 as an option. And if students thought about, okay, I have 3/8, but then what's the whole? And they're thinking about 8/8 subtracting 3/8, so 5/8 would be another possible way students would think about it, and that's also a choice. Or students forgot that there are 3 parts to that whole, and they just and they actually found the common denominator. They add 5/15 and 6/15 to get 11/15, and then I see that is also an option or a choice.
Yeah, exactly. And so that's exactly where we were going with this. So the few people omitted this question, but only 30% of the class got it right. Half of the class went for this particular distractor, right? This incorrect option. And so there's a misconception here. And in fact, there's probably 2 misconceptions because a large number of the students are choosing a precise, the same incorrect option. But one thing that I think is important to do when you look at the data is okay, so yeah, we know that they are making some mistakes, but also we should take a look at what do they do know? The students who did this, they do know something, right? What did they know to do? Even though they may have not done it correctly.
To add the fractions.
Exactly. They know that they had to add those 2 fractions. They know that. So they can interpret some of these things, and they do have some understanding of what's going on. Then the students who did this, they also knew that they had to add the fractions, but also they also knew how to add the fractions correctly, right? So that's the correct sum of the 2 fractions, 1/3 and 2/5. If you found, like Amy said, you found common denominators. Right, so you have you go to 15s, yeah, and then you get 5 plus 6, yeah, 15s. So you get 11/15. They know that, but they didn't subtract from 1, right? They didn't look at the portion of the shaded area, which is sort of the complement of the whole. And I think, Amy, you said this, right? What the students who made this mistake, they actually had, so they seem to have had the reasoning, the logical reasoning. They got it right. They knew that they had to add the fractions. They added incorrectly. They added across numerator and denominator. So, but then they knew that they had to subtract from 1. So if the fractions added, if the sum of the 2 fractions is 3/8, which is not, then the shaded part will be 5/8. So so students are making some logical choices. They're just making certain kinds of mistakes, but it's good to know what they get from the problem as well as what they don't. Yeah. So for the rest of our conversation, what I would like to do is try to give a few suggestions on what to do when you have the data. You analyze the data, and now what? You have your students in front of you, and you have, if this is the beginning of the year, you have the whole year to work with them. So what we suggest is that and this doesn't have to be just MDTP tests, of course. Assessment is something that is done both formally and informally, and it should be done pretty much every day, right? You have to see you have to check and see where your students are, so you can make decisions on the spot and plan ahead as well. So you should assess your students regularly to make, so you can know what you're doing, so you can make your decisions based on evidence, yeah? And you should try to figure out what do they actually do know, what they can do and what they understand. And you can then, so this is where they are at, and you can build on that to try to bridge to where they need to be. And so you try to map where they have to go to be ready for the next course, okay? If you can, you should try to look at the common misconceptions that they have, or the common mistakes and basic, for example, if there are some skills that are lacking, try to map them back to, is there a misconception that leads to these errors? Okay, so for example, in the problem that we saw before with what integer is closest to 31/5, you can try to figure out what students know. And, most of the class, those who chose 4 and 5 as their choice, they know that 31/7 is between 4 and 5. So that's a good thing, and it's a good thing you can build on. What do they need to know? Well, they need to be able to correctly go between fractions, or in this case, improper fractions, and on mixed numbers, right? So this 31/7 is 28 sevenths, which is 4, plus 3 sevenths. So 4 and 3 sevenths, okay? And then, of course, in this case, they also probably need to have a little bit of common sense with benchmark fractions, like 3 sevenths. Why is that less than 1/2, right? You can also try to see if you're going to be bridging the knowledge that they have now to what they need to do in the future, to try to see where this sort of skill or concept is going to come up for the students in the future. Okay, and so when they're looking at the slopes of lines, they're going to have to deal with these sort of fractions. Later in geometry, and also even in pre-calculus, I think they're going to have to convert between radians, when they're looking at angle measures between degrees and radians, and they need to figure out how many times around the circle you go, where do you land if your angle is something like 17.5 or 6, right? How many times around the circle are you going? Where do you end up? And you can try to map the errors to where they come, if you can try to look at the standards and see where students are maybe having a weakness in their conception or in the conceptual understanding. Okay. As another example, the other example that we saw, what do students actually know who answered this question? Okay, so a bunch of them know that they needed to add fractions, right? And that they knew how to add fractions with different denominators. So those who chose A and D, they added fractions correctly. And also those who chose A and C, 4/15 and 5/8, they knew that they had to subtract from 1. So those are things you can try to build on when you're addressing these problems. What do they need to know in order to do this problem? Well, they need to add fractions with uncommon denominators, and they need to subtract the area of the region from the whole, which is what Amy was describing when she was describing the item and what students had done to arrive at these different options. Yes, and again, you can try to see, okay, where am I going to have to deal with this when students are when they go to different classes in the future? Well, there's a bunch of places where these things are going to come up. They're going to need to deal with this sort of manipulation of fractions when they're doing systems of equations, also when computing areas and lengths and volumes of geometric figures, and then also, of course, when they start looking at rational expressions and rational functions. And even in calculus, when they need to integrate rational functions, they need to decompose into partial fractions. So they're going to need to deal with generalizations of these fractions, then things that you need to add that look like fractions, right? And again, you can try to see in the standards, okay, why are they adding across? When did they first encounter this in the standards, and what is the misconception that they may have from the very beginning there that is leading to this mistake? Okay. All right. So a few suggestions that we have for bridging your students from where they are at right now and to where you want to take them are these three that we have here. You can try to embed some small lessons that address the misconceptions that you see. Okay, you can try to you should try to make the learning transparent to students, so they know and they can have more agency and more ownership of the learning, and you should try to provide several opportunities over time for them to master the skills and the concepts that they're still trying to build upon. Okay, so a few strategies for bridging for making this path is you can try to. I'm going to stick with the example of fractions. So if the students are making mistakes with adding fractions, for example, or in general with manipulating fractions, try to make the math messy so that there are fractions in there, not just integers. Try to, again, distribute the learning over time. You can use some of our written response items or formative constructive response items. And you can also send students to some of the learning modules. If you see that they're making a mistake, like the one about adding fractions, there may be some learning modules that they can try on their own. And you can also have students write parallel problems, and you can actually have them, you can give them a blueprint of what the test is going to look like and say, okay, you guys write the problems and I'm going to collect them, and I'm going to maybe have some of the exam problems come from you. Okay. So making math messy, for example, make sure that you bring in fractions in the prompt of the problems, in the solutions. Sometimes students, when they read a book or when they see a teacher in the front of the classroom, they may think that it's supposed to look pristine from the very beginning and it's supposed to be perfect from the beginning. But no, when you're working through a math problem, it's messy, and sometimes you just have to backtrack and you have to try something new. And I think it's important to be honest about that with your students and show them how you are thinking about a problem, how you're thinking about how you think about adding fractions, for example. Why does it make sense to do it in a certain way and not in other ways? Give feedback to them when you see what they are doing. Have conversations so that there's some discourse going on, and that will make it would be easier to get a deeper understanding of what's going on. Okay, things of that sort. Also, this idea of spiraling and distributing the learning over time, you can make sure that they have opportunities to keep practicing these skills, and then eventually you can start adding some variables in there. So now they can add fractions or expressions that are actually rational expressions with different denominators, and eventually they're going to be able to add rational expressions. The concept is exactly the same as the one for adding fractions, but now they have to do it for rational expressions. Okay. An example of written response items is that you can, for example, see this is a question from a multiple choice test, from a diagnostic test, and it's asking the students which of the following fractions that you see in the box is the greatest. Yeah. And if you look at what students did, okay, so the greatest fraction here is 11/12, and 35% of the class actually chose that. Yeah. But a big chunk of the class, almost half of the class, chose 3/4. Okay. And so, well, first of all, why do you guys think that 3/4 was such a popular choice? You have any insights about that? So but whatever they did, the point is that sometimes from a multiple choice test, you don't have all the answers, right? We don't know if it's because, okay, they identified 3/4 and this is a benchmark, and so let's put that one, or if it's because they don't really understand that you need to look at the relationship between the numerator and the denominator. It's not just the size of the denominator that matters. So what you can try to do is give them a written response item where students actually have to write out solutions and explain what they're thinking. And then you can get a much better understanding of where they are. So an example here is an example of a written response item about comparing fractions, it's framed as a debate between students, which one is bigger, 3/4 or 7/8. And then the task is for the students to support one of the students who is right and why, and explain in your own way. And then you can see, for example, here's an example of a student who answered using diagrams. They found common denominators, and then they used diagrams to show that some numbers are bigger than others once you convert to denominators. Here's another example of a student who also found common denominators, and then they converted to decimals to compare the fractions. So then you can get an idea of how they're thinking about it and how they're communicating their thoughts. And written response items come with general rubric for scoring all of them. And also each item comes with a complete, what we call an essence statement that has a complete description and a complete solution of the problem. And it also comes with a particular rubric for that item itself, so that it gives you guidelines for how to grade it. Okay. Another suggestion that we talked about was to write parallel problems. And so you can have students in small groups write problems, giving a blueprint of what the test should look like. And then they can swap the problems with each other so that they can give feedback to the students. The other group can solve the problem and criticize the problem. And then eventually they turn in their final proposed problems. And then you can choose some of those to actually give in your exam. And it's really, I think it's a really good exercise for students to actually try to put themselves in the shoes of the teacher and write, what does it mean to write a good question for a test? To have students think about, so to answer the question, they have to think about the concept and the skills needed. You can do some of the other type of written response, of open response items, the formative constructed response, which are geared, remember, these are, you give a diagnostic test, and if you look at an item, especially in a topic that you want to pay attention to, you look at an item where students didn't perform very well, you can try to look for formative constructed response items that address that item, and you can then, so the idea is you actually have an intervention, so you make some instructional, you address the issue in class, and then you give them one of these items to see if they are now getting it. Okay, in this case, you could look into questions about adding and subtracting fractions. Okay, and here's an example of such an item for adding and subtracting fractions, which is very similar to this is a spin-off of the problem that we saw about the circle, yeah, where students they need to explain how they are thinking about this, how they're doing the computations, and how much is left over after you add these two fractions, yeah. So you have just like for the written response test, you also have an essence statement and a rubric for scoring the item. Okay. So the last thing I'm going to talk about is when you're trying to address the issues that come up when you look at the data for your multiple choice test or even for your open response test. When you're trying to bridge, you want to build on from what students are, from what they know, but you want to bridge so that they're ready for the next course, and that you want to take them there in a manner that is equitable, so that you can engage, so that you can bring everybody along, everyone in the class. Okay, and so for that, I think it's important to try to think about the different types of engagement that you have for different kinds of content that you're going to deliver. So when you're introducing a concept or this is when the students are first looking at it, the first time they're seeing it, okay? And they're exploring the strategies for how to use them and developing their skills and to be able to apply these concepts. But when you're advancing, that means that students have already had some time. This is not the first time they're seeing this content, but now they're advancing. You're advancing their knowledge, and you're making their skills better and more diverse, so that they are able to solve and to apply them these concepts in a wider range of contexts, for example. And then there's the re-engaging. So when should you re-engage with some content? Well, there's two kinds of things, two kinds of situations where you want to have some re-engaging with your class. One is when you're about to go into a new concept, okay? And so you want to activate the prior knowledge to make sure that we start from a place that we all are comfortable with, okay? And the other is when you look at something like an assessment and you find that there's some misconception that needs to be addressed, okay? And so this business of re-engagement really is different from just reteaching the concepts, okay? Because with reteaching, essentially you're just teaching the concepts again. You're teaching the unit again. Whereas when you're re-engaging, you're actually trying to revisit what students, the student thinking, what they already know. When you're reteaching, you're basically addressing again the same skills over and over, the same skills that they are missing, that students are making mistakes with. Whereas when you're re-engaging, you're trying to actually address the conceptual understanding that's leading to those skill mistakes, lacks in skills, okay? When you're reteaching, essentially you do, a bunch of problems over and over, the same kind of problems over and over again. Whereas when you are re-engaging, what you're trying to do is create some discourse in the classroom so that students can talk to each other. You can be a part of a conversation. You can look at how students have different ways of thinking about it. You can critique, or you can have students critique different ways of thinking about it, and you can make connections between the different approaches and the skills and the concepts and things like that. Usually, when you're reteaching, you focus on the students who are missing, who are making mistakes. Whereas when you're engaging, you are bringing the entire class along with you, because we're talking about conceptual understanding. We're talking to each other. We're critiquing different approaches, and so the cognitive load is much higher when you're re-engaging than when you're just reteaching something. Okay, so I think it's a much more worthwhile experience for the students if you try to engage in, if you do some re-engagement rather than just reteaching. And a few of the strategies for these different kinds of engagement are for introducing a concept. When students are first learning the content, what you can do is have students independently work on a problem. You should monitor what they're doing, and you can choose a few of their work to present to the class, and you should align it so that it fits with your plans. Okay, so you can look who did what, and then you can select the ones that you're going to present and in what order. And you can then, when you should plan, you should anticipate what the mistakes are going to be and try and make sure that you address those in your class. Okay. As always, you should assess how the students are learning this, and you should always provide feedback to the students. That's something that should happen continuously, right? When you're advancing content, so the students already know a little bit of this, and you're just bringing the content further, or you're trying to make their skills deeper and more flexible. What you can do is collaborative work, so small works, small groups, and students can then present. For example, they can do posters and post them on the classroom, and then you can do gallery walks. You can actually keep those up, so you can chart and you can give names to the methods that students are coming up with, and you can keep referring to them during your instruction. Okay. And again, for re-engagement, there's two kinds, right? When you're activating prior knowledge so that you can go to a new concept, make sure that you meet the students where they are. So you take pause, so it says here, make sure that that you can actually go there by knowing that the students are with you, and you know what at what level you're going to have them to advance this knowledge. Okay. And If you're trying to re-engage because you're trying to remedy this misconception that you saw in a diagnostic test, for example, what you should try to do is not be too ambitious and do a little bit at one time, and over time build on this on addressing these misconceptions, so that you give students opportunities to remedy these mistakes that they're making over time. Okay, and again, you can have student work on the classroom, so you can refer to it when you're having discussions with them, for example. Okay. And I think that's pretty much that's it for the class that the conversation I wanted to have with you guys today. This slide and the next one just has some links so that you have some resources to MDTP. Okay. We have some recommendations for testing. We have the guidelines to inform the next course enrollment. And we have some webinars that you can look at in our website. And we have newsletters. We also have some contact information and links to the different kinds of tests that we have. Okay. And if you ever have any questions about MDTP, feel free to give us a call, shoot us an email, and we'll be happy to try to help and to work with you. So at the bottom, you can see Kim. Kim's the statewide director. And the email for their office is mdtp@ucsd. And then if you are in the UC Berkeley region, I think, Linda, I think you are in my region, but I'm not sure. I think you are in Livermore. I'm not. And you can just shoot us an email at mdtp@math. That will be Jacqueline and me. Or you can just shoot me an email. That's my email at the very bottom. Okay. So I'm going to stop the share. And I want to say thank you so much for staying with us here, even though it's such a small group. So I really appreciate it.
Thank you. Thanks.
Bye, everyone.
Bye.